Okay, good morning. Welcome to the first session after the keynote. Welcome to the Fast Data Theatre here at Big Data London. My name is JAKUB. I'm a Senior Manager in Advisory Architecture at Confluent. And today I'm going to be talking to you about rapid cloud data migrations using Confluent Cloud. So let's take a look at what we're going to talk about today. I apologize for the small writing. I didn't realize the screens would be so small. So firstly, we're going to talk about the drivers and the characteristics of data migrations. We're going to talk about, I'm going to introduce to you the paradigm of streaming ETL, extract, transform, load. I'll give you an overview of the Confluent ecosystem. We'll talk about how to lay out a migration, both logically and physically in space. And then we'll talk about what it actually takes to execute the migration. And finally, we'll do a little bit of a wrap-up. So let's consider why we need to perform a data migration in the first place. And it generally comes down to this one headline topic. There is a re-architecture going on somewhere within your organization. Systems are shifting around, databases are being consolidated, that kind of thing. What types of re-architectures are there? Well, firstly, we've got decommissioning of old technology. So you've got things that have come to the end of life, end of support. Maybe the licensing costs, the annual costs are getting too high. You want to move to something a little bit different. You have a cluster consolidation where you have many databases that have sprawled around the organization. You want to bring all of that data together into one centralized infrastructure. You're trying to gather some operational data for analytics. This is a common thing. You might be moving things over into a data lake, data warehouses, that type of infrastructure. And then finally, a big driver is company mergers and acquisitions, where you have similar architectures in companies that you have just acquired. You're looking to actually bring them over into a single consolidated view. So what are some of the characteristics of a data migration project? Well, one of the big truths about migrations is that they're not actually just about the data. You have to think about the teams that are involved in building the systems around the data itself, who are operating with it. These teams have their own timelines, they've got their own commitments to the business. Often the migration is one of many things that they are doing at the same time. You have applications built by those teams that have particular uptime requirements. So you can't afford to just turn things off, move some data, and then start it up again. And then finally, you've got the data itself. The data has to move into a different location. It has to move into the shape and the representation that it's going to look like in that final destination. And it needs to be available throughout the entire data migration process. This makes it tricky and requires a fine level of choreography. So let's take a look at some of the reasons that data migrations are always hard. Firstly, you've got heterogeneous data systems. You're typically talking about different technologies between the source and the target. You're looking at different data formats. Data has to be reshaped from the source system to the target system. And you've got different APIs for the systems that interface with that data that they then have to adopt. These are typically not one-off processes. That may have worked 20 years ago. It doesn't work now. The publishing and consuming systems for this data require operational continuity. And finally, you've got resourcing. You have a group of people who is usually overloaded doing other things. They have particular skill sets. You've got usually a limited amount of time to get the data migration done, and you have a limited budget in order to achieve it with. And if that wasn't complicated enough, we now have to deal with the process of data migration in different modalities. What do I mean by that? Well, firstly, we've got data migrations within an individual cloud environment, particularly in terms of consolidation of resources. You've got hybrid, where you're moving data from on-premise, you're moving it to the cloud. And then you've got multi-cloud or multi-cloud organization. So if your organization uses a particular cloud vendor, you have different billing accounts, those things are probably ending up in different parts of networking infrastructure, etc. So whatever approach we use should really start to think about, take all of those things into consideration. So let's take a look at what migrations used to look like. The top left slide shows two applications, a writer and a reader talking to a source system. Let's say that it's on-premise. The location doesn't really matter. The target system is somewhere off in the cloud. A typical migration used to involve turning off the writing system, spinning up some type of ETL process to extract the data, transform it, and then load it into the target system. And then you would move the applications across, usually with some sort of rewrite, because you have different technologies involved with different APIs and different ways of accessing that data, and decommission the source system. So we think that there's a better way of going about doing this. The existing approach does involve a significant amount of downtime. When you're talking about relatively small databases, an ETL process might mean that you get the entire thing done in a couple of minutes. But when you're talking about moving gigabytes or terabytes of data, the processing of that, the process of taking a snapshot, processing all of that data, loading it into the target environment is going to take an incredibly long amount of time, which means a long outage period. So we'd like to introduce to this concept of streaming ETL. Streaming ETL means that it is a long-running process where it is taking changes from a source system, reading them into something, transforming the data and loading it into the targeting system on an ongoing basis. So let's break it down and talk about the Lego bricks that are involved in building this particular construction. The first one is Apache Kafka. Apache Kafka is an open source distributed event streaming platform. It allows you to write applications that send data into it and have other applications written that react to it and are able to take some form of action. Data is transmitted through a concept called topics. A Kafka topic is our primary construct for moving data. You can think of it as a tape. When new messages get published to it, they get written to the end of the tape, and systems that consume from it are reading from that tape as the data arrives. One of the interesting things about this construct is that if things go wrong, or if you want to subscribe to a different consumer, you can actually start reading from a different position in the tape and replay all of the data into whatever consumer you want. An event is the thing that gets sent over the top of a Kafka topic. It is a piece of data, and it's an indication that something has happened in the past. To interface with databases or data warehouses, we're going to use a platform called Kafka Connect. Kafka Connect is a tool for scalable and fault-tolerant data integration. You can kind of think of it as a cluster of application servers that run particular jobs to talk to a particular type of technology. Those things are called connectors. A connector is a library that talks to a particular technology type. So for example, Snowflake or Databricks or Postgres or Oracle or any of those types of things. Or it can also have a second meaning of being a runtime instance, which means that it is an instance of it that talks to a specific instance of that technology type. So it's saying you're talking to that Oracle database over there, or you are talking to that Snowflake over there. And finally, in order to put all of the pieces together, you're going to have something to actually do some data transformation. And this is where a streaming framework comes into it. So a streaming framework does the T in the ETL. It takes messages from a particular Kafka topic, it performs some sort of a transformation operation or joins data from different topics together, processes it in some way, reshapes the data, and then sends it off to another topic where it can be read. Now let's see how these pieces all come together. We have a source system. We set up a source connector inside Kafka Connect that reads from that data system. It writes it to Kafka. We have a stream processing application that actually does the transformation logic on that. It writes it to another Kafka topic, writes it to a sink. A sink connector goes off and reads that data and loads it into a target system. That's not all that Kafka does, because you can also have just regular applications written in your language of choice. So you can take your existing business applications and get them to produce data into Kafka and to react to data as it's changing within Kafka. So the nice thing about this entire ecosystem is Kafka is free. You can go off and you can download it and you can load it into your cloud environment or on-premise environment and don't have to pay anyone for it. So it's free like in beer. The thing is, Kafka is also free as in puppies. That if you got a puppy for free, it's a very fortunate situation to be in if you happen to be a dog lover. You still have to feed it. You have to take it out for walks 3 times a day. You have to take it to the vet. The costs mount up. These are operational costs of living with that particular thing. So the company I work for, Confluent, we have a platform called Confluent Cloud. And Confluent Cloud is a managed Kafka ecosystem. So it's all of the different components that I've already mentioned to you. It's cloud native, which means it's scalable, it's resilient, you pay for what you use, all of the things that you expect from a modern cloud service. It's complete. It has all of the different components that you actually need to get the job done. And it's everywhere, which means it runs in all of the major cloud providers. It's a case of subscribing to the service. A few minutes later, it's ready to use in whatever cloud environment. AWS, Azure, GCP. Confluent also we have an on-premise offering or a self-managed offering, which is separate Confluent platform, which you can use for environments where that doesn't apply for you. So if you think about the puppy analogy, if you have an open source Apache Kafka and you run it on cloud, typically the servers are provided for you, but you still have to run your VMs, your operating system, your JVM, you have to do your Kafka patching, scaling, load balancing, all of those types of things. If you go to other vendors' installation offerings for Kafka, you'll find that there's more things that are done for you. With Confluent Cloud, we're the only vendor of this type of technology that gives you a fully managed offering across all clouds where you don't have to think about managing any of the infrastructure. This is a significant time saving because your teams don't have to worry about setting up this infrastructure. They can just go off and actually start using it. So with this particular technology, we go from, if you wanted to go off and build this thing yourself, build all of the infrastructure in order to achieve these aims, you'd be looking at months of provisioning, getting your processes right, etc. If you go to other self-managed Kafka services, it's weeks, whereas this is an offering that you can use in minutes. The offering is complete, which means that we have a suite of products around Kafka itself for data governance, security, fully managed connectors, which means that, again, it's a case of point, click, it's available to you, you're ready to start ingesting data or writing data out to target systems. We have a stream designer to help you out with the stream processing. We have stream processing that allows you to use the skills that your team already has to allow you to write SQL over the top of a stream of changing data. In the context of a data migration, we're talking about inserts, updates, deletes. Combine that data, modify it in some way, and load it into a topic. We provide monitoring, and we provide global resilience. In terms of the connectivity, we connect to pretty much everything that you would like to connect to natively. So everything from MongoDB Atlas, Databricks, Azure Data Lake, various messaging systems that you've got around the place. And all of these are fully managed, which means that you don't have to go off, build these things, you don't have to load anything there, it's ready for you to go. We also provide the capability to run, for you to run other connectors within our environment as well. As I said previously, we are everywhere. So we're everywhere that your data happens to be. Let's talk about how the migration might actually be laid out. I'm going to take you through two different sets of diagrams. The first ones are logical diagrams. We're going to make Kafka transparent in this. We're going to just focus on the topics and the components that are actually performing actions. What I'll do then is I'll lay it out in terms of physical architecture and where each of these components lies in the different modality types. Data pipelines for doing data migrations come in three different complexities. The simplest one is where you have a source system and you want to take the data and copy it exactly as it looks like into a target system. You set up a source connector, you write it into an input topic, you have a sync connector which reads from that topic and writes it into the target system. This is particularly handy if you're moving a like for like. If you're performing a like-for-like migration, so you're moving from Postgres databases to Postgres databases, or Mongo databases into MongoDB Atlas, as examples. Where you need to have some sort of a transformation, we get into a medium complexity data pipeline. Again, we're reading from a source system, writing to an input topic. We then have to introduce a transformation process through KSQLDB, which is our native SQL interface into event streaming, or through whatever other platform you want to use for event streaming, for event processing, and then write it out into an output topic. From that output topic, we take a sync connector and write it out into a target system. Finally, the third one is what we call a high complexity streaming ETL pipeline, where from a source system, you might have different types of connectors, or different connectors that are reading different data, or different subsets of data, writing it into separate topics, and then you have to combine them, join them, window them, group them, do all of that type of thing. And this is where your stream processing framework of choice, whether that's KSQLDB, Kafka Streams, or Flink, they'll be doing the transformation, the joining of these events, the recombining of them, usually into a good use case for this is where you have highly normalized data and you want to denormalize it in order to load it into a document database, as an example. You write the output into an output topic, then you have a sync connector that writes it into a target system. So each of the data pipelines that you use to perform data migrations are going to fall into one of these three categories. So let's now take a look at the physical aspect of it and see how these components would be deployed in space. So if you have a single cloud environment, we have Confluent Cloud that runs the source connector, the transformer, and the sync connector. That's your event streaming pipeline in there. That's a medium complexity one. You've got the source systems and the target systems hanging off on the sides. What we would do, we'll go through the actual process of moving the applications in a couple of slides. If you're migrating data in a hybrid environment, things get a lot more complicated. Primarily because of your InfoSec requirements. Because typically, your infrastructure teams do not want cloud systems to be reaching into on-premise environments into your own data centers, retrieving data, and then pulling it back out. They see that as a security risk. There's a couple of different ways of going about it, and we've written a white paper that goes into a bunch of different options for these types of deployments, along with the technical considerations that it takes to perform these types of migrations. This is one of the various flavors. We would run Kafka Connect standalone inside your on-premise environment. It is connected over to Confluent Cloud. A source connector reads from the source system, and the rest of the processing is performed in Confluent Cloud once the data is written from Kafka Connect into that input topic. In a multi-cloud or multi-environment organization, or a multi-organization environment, if we've got two different cloud environments, let's say that one is on Azure and one which is on GCP, you set up two separate Confluent Cloud deployments. We set up a source connector to read from the source system in your source environment, write it into an input topic, have the processing done in the Fire environment, and have some sort of replication between those two environment types. There are a number of mechanisms that we provide in order to allow that type of mirroring. We have a mechanism that comes out of the box. It's very straightforward to set up, called cluster linking, which allows us to perform source or target initiated links between these environments. But there are other options depending on how your networking is structured within your organization and what the policies are around data transfer. So let's talk about how you actually go about executing a migration. We've seen what the logical structure is, how all of the different pieces fit together and how they're deployed into space. But let's talk about the process itself. With streaming ETL, we have a writing application and a reading application that talk to an on-premise data system, some database. We set up a streaming ETL pipeline that absorbs all of the data, it ingests it through Kafka, processes it, and in real time starts writing it out into the target system. So as changes are happening inside that database, let's say that it's an Oracle database, then those would be getting written across on a per operation basis. So every single insert, every single update, every single delete to a record is getting processed through the pipeline and is getting written. So what you have is a complete replica, potentially in a completely different database type, which is now ready to read. The transition point is we take application B, which is the reader, we disconnect it from the source system, we start a new version of it in the target system, and it starts to read things on an ongoing basis. There are certain considerations that you need to put into those applications around when exactly do you start? How do you deal with duplicate messages? How do you make sure that you don't skip certain messages? All of these are described in the white paper. Finally, what we do is we move the writing application and decommission the source system. No downtime other than the rolling deployment that it takes to disconnect the reader and restart it in a different location. If you've got multiple consumers, the process is very similar, where we take one application, one reader, move it over into the target system. We take the second reader, move it into the target system from the source system, and then finally we move the writer. Now there's a key point here, because in making these moves sequential, what I haven't said so far is how long it's taken to actually do this work. And the beauty about this approach is it doesn't really matter. Previously, when we did data migrations, we had to arrange the work of all of these teams so that they were ready to disconnect from the source system and move to the target system all at the same time in lockstep. What this allows us to do is to decouple that movement of applications across time, which means that that application, the first reader, once it moves, the time between the first transition and the second transition might be weeks. It all depends upon when that particular system is available. Because the data is being copied across and translated on an ongoing basis, this entire migration process is effectively, as I said, decoupled over time. The beauty about this process is I've shown you a very tactical way of using a capability that can also be highly strategic to your organization. Data streaming changes everything. It changes the way that you go about doing business. When you think about the number of times in a standard organization where you have data getting out of sync with each other, data streaming addresses that particular problem. So let's say, for example, in a source system, you want to change an address of a customer, and that has to get propagated over to 10 different systems. Previously, it required batch processing to make copies of that database on an ongoing basis. Often those databases would get out of sync with each other. What about if we use the migration process as a stepping stone to allow those systems to be in sync with each other all the time? So as the customer contact point is happening, it gets propagated immediately around the organization. So this streaming ETL pipeline, we introduced the source connector, a transformer, a sync connector separated by two output topics. The output topic contains data the way that it should look in a target database available for reading. One of the nice things about it is we can actually go think about, well, what about if we built a native application, a native business application, hooked it into that output topic as a consumer, and we can now react to those changes as they're happening in real time without the need to read anything. It's literally the data that's being pushed to you, and it's enabling a new business capability. The question then becomes, well, I wanted to decommission this source system. What do I do with the writer? Well, instead of taking the writer and rewriting it so that it writes into the target system, why don't we change it so that it writes natively into Kafka into the output topic? We now maintain the read capability in our target system for the applications that need to read things. So, for example, our reports, our analytics systems, etc. And we can have real-time reactions to business data as it's changing within the enterprise. And we've done that using the same building blocks for the migration itself. So in summary, we spoke today about the drivers and characteristics of data migrations. I introduced to you the streaming ETL paradigm and why it's much, much better than doing things the old way. I gave you an overview of the Confluent ecosystem. We spoke about how to lay out all of the different components in a logical and physical manner, and we spoke about the process of executing the migration. If you'd like to find out more, we've just launched a new white paper, which is at implementation level, which looks at all of the technical considerations that you need in order to perform a data at rest migration using Confluent Cloud and streaming ETL. In that white paper, we've got a case study of one of our customers, ODP Corporation, who run Office Depot in the United States, and where they talk you through a journey where they consolidated multiple databases into a single piece of infrastructure using these same approaches that I have just outlined today. So I'd highly encourage you to go out and download this white paper, read through it. There's a lot of diagrams in it. If you like diagrams, it's very easily understandable. If you'd like to find out more, I'll be available today at the Confluent booth, which is just over there. I'll be very happy to talk through the process of your data migrations and answer any questions that you may have. If you'd like to get started with Confluent Cloud, we have a sign-up code here where new sign-ups receive $400 to spend over their first 30 days. So you can play with this technology, get your feet wet without any sort of additional commitment, try it out and see how it fits your teams and your way of working. So thank you very much.